All right, guys, so let's see if I got a slide for this. I don't think I do. Let's build a smart contract. We've done that. Let's unit test the smart contract. So look, arguably this is something that we probably should have done before we deployed the smart contract even onto the test network. But look, better late than never, right? And it depends on how cowboyish you feel. And maybe you just want to actually deploy something to the testnet to let everyone have a play with it and your confidence going. Anyway, all these excuses that we have for not doing unit testing can apply here. But what we're going to do here is I'm going to start from scratch. We're going to copy over the smart contract, so don't worry, I'm not going to redo that again. But just because the tool set we're going to use is a little bit different, so I'm going to use, just hit the play button on that, Truffle and Ganache. So Truffle is, as Kevin was saying earlier, if you remember, it's the tool set, it's like your Swiss Army knife for dealing with Ethereum network and things like that. It's good. Some problems with it, like for example, the Solidity compiler version that it integrates is never the latest one, and that's an issue for me when I want to use the latest features and all this kind of stuff. So that's why I think let's just start from scratch and do it with Truffle. And like I said, a lot of the tools in this space, a little bit immature, and the way they kind of integrate with each other needs some work and things like that. So this is one reason why I'm choosing to start from scratch for a smooth operation. So Ganache is a personal Ethereum blockchain. So like Rinkeby runs in the cloud, and there's all these nodes, and they all talk to each other. We're just going to have one node that's going to run on my machine, and it's going to be for the purpose of running unit tests. So let's see. So let's do some setup for Truffle. Okay, so we'll do Truffle init stuff sid js sets. Should create the directory. Okay, sorry. Oops, make dir, sorry. Right, okay. Now we do Truffle init. So it kind of just creates the same way, kind of like npm init or yarn init or whatever, creates like a whole bunch of things. What do you call it? Like utilities and things like that for us to actually start our project off with. So you can see it's created a whole bunch of files, contracts, migrations, test, everything like that. I'm just going to move that thing in the background out of the way. Maybe we can see it a bit easier then. Is that better? All right. Okay, so what do we got here? Let's actually have a look at it with Atom. Let's close that one down, actually. Try that again. All right. So it's put in a migrations.sol file. We don't have to worry about that. Some other little bits and pieces and a test directory. So this is kind of like where we're going to focus most of our attention tonight. But before we do that, we've got to do some setup. So just bear with me while we'll do some Truffle setup. If I just jump into my, where is it? Notes here. Right, so we've got to populate the deploy contracts.js file. So once again, you know, I would have expected this is created for us. Well, this is some setup we have to do. Okay, so this is going to be the thing that Truffle needs to deploy. So it identifies our contract, and just deploys it essentially. So you don't need to write code like I did in the last thing to deploy it. You can use Truffle. But sometimes there's problems. So sometimes you want to take control yourself and actually use your code, write code yourself. Okay. Right, we need to add the Solidity code, so I'll just go and grab that again. Okay, good. Now we need to create that in the contracts folder. Save that one as well. Okay, so let's just check if we can compile that. So the good thing is I don't have to use the Solseek compiler directly. Truffle takes all that away from me, all that responsibility away from me, so I can just run Truffle compile Let's see what happens. Okay, all right, so we got an error. Now the reason we got that error is because Truffle is running a few compiler versions behind, and it doesn't like us to use the emit keyword there. So let's try that again. Oh, look, and because it's complaining about our enforced compiler version, so I've got to fix that as well. I think it's running on 19. Oops.
Does it not pick up automatically?
Sorry?
Will it not pick up automatically?
What do you mean by pick up automatically?
Automatically picks up, gets it from the background, the version of the
file. So what the thing is, by putting this in the file, I'm saying don't let any compiler earlier than this version compile this file. So Truffle is running a compiler version. Let's see, here we go. You can see it there, version 19. And there's no way to actually say, hey, Truffle, use a later compiler version. It's like you got to wait till Truffle updates.
configuration file where you can already set it and then it automatically reads.
Unfortunately, no. Maybe later. You know, it's one of these things where the tools are quite immature, right?
How like in time, how much time is between 19 and 21 for miners? Like how far behind is Truffle?
Oh, look, probably about a couple of months, I think. Yeah, about that.
And is Truffle open source as well?
Yes, it is.
It's scripted, I'm sure as well, like C++, Departure, JavaScript.
Well, Truffle runs on Node, so it's just JavaScript.
It file from something else, or
Look, there's some Babel in there and stuff like that, but you know, no. So it just runs Sol-C, which is the compiler, which is written in I think C++, or yeah, I think it's C++. So Truffle is kind of like your Swiss Army knife. It doesn't actually compile anything itself. It asks the compiler to do it, but it comes bundled with the compiler. So you can't change that unless you modify Truffle quite deeply. There's no like, oh, I'll just swap out the compiler, which would be nice, but you know, maybe later. I think that's the intention. They're going to get to that point, right? All right. So let's just configure with our, continue with our configuration. So we've changed that now. Let's try the compilation one more time. Good. We've got now some output in build.contracts. So if we look at our build contracts, you can see the same kind of JSON file, nicely laid out this time, but it's the same thing as before. When we compile to like the JSON file. So Truffle does things a little bit more differently, a little bit more prescribed. I'd recommend starting with Truffle if you want to have a play, because you know it is as simple as just running like some things in the command. The documentation's okay. You know, it's a good place to start. So what we've got now is we've got our contract. We've been able to compile it. We need somebody to deploy it to. So let's fire up Ganache, which is your personal private blockchain. So let's just have a quick look. Oh, down here. Let's look at that. So yeah, quickly fire up a personal Ethereum blockchain, which you can use to run tests, execute commands, inspect state while controlling how the chain operates, because we have 100% control over it. And we can reset it any time we like. So let's have a look at the GUI. Can we zoom in on that? That's big. Okay, so what happens is it comes with a bunch of accounts. What is it? I think it's 10 accounts. We can see the private key for each account, right? So we can easily you know, work with it and test with it, mess around. We've got our RPC server. So this is our URL. I'll just zoom in and see if it zooms in. So this would be used instead of Infura. So last time we were using Infura, we just used this, yeah? And it's doing some auto mining for us. And we have a look at the blocks, just a Genesis block. Nothing's happening so far. All right, so what we have to do now in order to deploy our smart contract onto our Ganache server, so we're not going to deploy it this time to Rinkeby, we're going to just deploy it locally, because that's how we want to run a unit test, right? Don't have to run unit tests on Rinkeby. We've got to modify the Truffle.js file, add some configuration to tell it where to actually deploy it to. So let me just grab my notes. Way down here. There it is. Okay, so what I'm telling here is, so here's all the networks I've configured. I've only configured one network, development, right? So you can configure other networks like mainnet and Rinkeby, other test nets, your mate's computer, whatever, right? To actually deploy the contract onto. Since there's only one network that I'm going to define, it's going to be as simple as just deploy. And it's going to say, well, there's only one network. Truffle's going to say, well, there's only one network. I know where to deploy it to. So let's give that a shot. Truffle, whoops, deploy, yeah? Okay, that looks like it was successful. Let's see what's happened on our personal blockchain. You can see now we got 4 blocks before we had, well, we got 5 blocks, sorry, block 4, because we start at 0. So stuff is happening, okay? That's a good sign. Our blockchain's increased in size. Let's have a look in the account. You can see that this is no longer 100 Ether. So we had to spend a little bit of gas to actually get that contract onto the blockchain. So this guy here is the contract owner. Yeah? So good so far?
Does that mirror the cost of Ethereum on the real blockchain? Does the testnet mirror the actual cost of deploying it to the real blockchain?
The amount of gas required to actually publish it is different on every blockchain. So I think we're just using defaults here. We've got gas limits and things like this. The nice thing about this is it's just, I'm not sure how configurable it is. I haven't actually tried to do it because I run a unit test, I got lots of Ether. I'm trying to do it. And if I want to make sure a test I run out, I'll drain the account of Ether and then try to actually run it, and I'll say this much gas. So I can control that with my test cases. Since that's never really been a concern.
There's actually 2 values. There's the amount of gas and there's the price that you pay for the gas. So the amount is the number of computations that you're going to do roughly, like the amount of space you're going to use on in terms of their CPU usage. But then the price you pay is based on how congested the network is. So it's really congested, you pay a higher price for the gas. It's exactly like going down to the petrol station. There's the amount of petrol your car needs to go, and there's the amount you pay for that petrol. That's the gas versus the gas price.
And I don't know if anyone's been following Bitcoin, but around Christmas time, like to do like a $1 transaction, it costs like $40 in transaction fees because everyone was trying to transact at the same time. Wasn't nice. Anyone who wanted to actually use it as a currency instead of an investment. But anyway, all right. So what we've done now is we've created a smart contract and we deployed it onto the blockchain using Truffle. Let's build some tests for it. So we go back to our source control, our source code, and we create a new file here. Let's call it, what do we call it? Stuff sid.js says.js. Yep. Just make sure I got this right. Yeah, okay, and we're going to add some test boilerplate here as well. This stuff. Oops. Right. So here we're going to create our contract. We're going to interface with a contract, and we get a bunch of accounts that come with that. Yeah. So underneath the hood, it's talking to Web3. Web3 is getting the accounts. In our case, the accounts come from here. Yeah. So the Ganesh has created these accounts. It's all a lot of convenience set up for you here just to run your tests. All right. Let's then write a test. Yeah. Without further ado. Well, we have to actually do a before each to set up the contract. Let's do that. So we create our mock contract object, and before each test is run, we create an instance of the contract. Now we're going to actually add a test. So let's make our first test to just check that the last amount paid starts at 0, yeah? So we know from our Solidity code that the last amount paid is initialized to 0, So we definitely don't expect this to fail. Just for fun though, let's make it a 1 and watch it fail, and then we'll fix it and then watch it succeed. All right, everyone with me so far? Yep. You guys do all the unit testing for breakfast, right? In your sleep, yeah? It's all, yeah. All right, so truffle test, another truffle command. Nice and easy. Let's see what happens. Okay, 0 passing, 1 failing. All right, let's see if we can fix that. Bam, passing. That's good. Let's add another test, a little bit more complicated this time. That one, I think. No. All right. I know where my formatting is. Look at these indentations, terrible. All right, so the second one is I'm able to update the message, right? So let's say the message is something wicked this way comes. I'll just put some text in there. We're going to try and use our mock contract and call the function on the contract update message. We provide the message and also an object in that where we have the from address. So this is going to be the guy who's actually executing that transaction. And he's going to provide some value. He's going to provide 0.02 ether. Yeah? So what we're going to check then, we're going to get the last message. So as soon as they've updated the message, we're going to interrogate the blockchain for this contract, and we're going to get that message. And then we're going to make sure that that message that we've just published matches the original message that we've got. Yeah? So let's try that out. Well, let's do what we did before and say, let's make it a failing case, right?
Contributor is defined.
Oh, yep. Forgot the dude. So the contributor is our user. And what this is saying is just get the first account from the accounts. So this will be this guy here. Oops, sorry, yeah, this guy here. 62730, etc., etc. Right, if we make it 2, then it's going to be this guy here, the C54D, etc., etc. Yeah, so it's just an array of accounts that come through for us to play with. Okay, so let's try and run that. And what we should see is that, actually, let's just to make this interesting, let's use the second account. I'm going to remove that. No, let's make it fail first. So the second account has 100 ether. So we should see that decrease as they attempt to mutate the blockchain. Let's give that a shot. Okay, so 1 passed, 1 failed. That's what we expected. Let's have a look at Ganesh, and you see that he had to spend a little bit of ether just to make that attempt, right? Well, actually, let's be clear about this. He actually successfully put it onto the blockchain, but the test failed because my test condition was testing a different string. So let's remove that different string now, and we should have a success scenario. Two passed, and once again, you can see the ether has dropped even lower now. Pardon? It dropped on account 1 as well? Probably because we're deploying the contract every single time. We have to set up a new contract every single time. I haven't noticed that actually on the testnet. Yeah.
Where is the ether going? There's a 0.057.
Where's the ether going? It's going to the contract address. So I don't think there's an easy way we can see that with our simple little Ganesh tool, but Kevin's going to demonstrate where the...
In general sense, it goes to the miners, right?
The gas goes to the miners?
The gas goes to the miners, yep. But when you're sending ether, so in this case here, I'm sending this much ether because I want my message to be more than the last guy. I'm sending that much ether, and that goes to the contract address. So then you, in theory, write a function to move that Ether out of that address to someone else's wallet, right? And the owner should. Let's leave it at that for now. All right. Okay, so let's add yet another test. So a little bit more complicated again. This is going to be our last test, so don't worry, I'm not going to write a whole library. We're going to check that the last amount paid is correct. So I'm going to change the message to whatever. The ether to contribute will be 2.5. So, you know, that's like $1,500 worth of ether or something these days, maybe more. And all to just update the message to something really sarcastic. So we're going to call update message on mock contract from the contributor once again, which is this second account. The value is going to be the ether to contribute value converted to Wei, because every time we interact with a smart contract, we have to use Wei, not ether. Right? So we've got to actually add all the 18 decimal, and we have to make it an integer. So how do I describe it? Yeah, it just gets converted to Wei. As you remember before, 1 ether equals 18 decimal places. 1 Wei equals 18 decimal places of ether. We then convert that the last amount paid number from Wei, the last amount paid from the actual contract, and then we compare the two. Yeah? So let's have a look, see what happens for our test cases. It should succeed. Whoops, did I hit save? Didn't hit save. Try again. Okay, num from Wei is not defined. Yes, that's because, Kevin, you didn't point out I had another error. What are you doing? All right. I need to put this up the top. So this is our function num from Wei. So as you can see, all it does, it takes a big number object. So this is like a, it's a object which stores a very, very large integer. We convert it to a JavaScript number for comparison.
Because JavaScript's really bad with numbers, so anytime you use numbers with smart contracts, you need to basically use a library, because JavaScript can't hold big numbers that you're dealing with. And if you try, you're going to lose precision, and I don't know about you, but I don't like losing my money. Or adding 0.1 plus 0.2 type of things. So that's why we use big number libraries of some kind every time we're dealing with this smart contract.
Okay, so I've got an error that I actually need to figure out. Expected 0 to equal 2.5. Can anyone see the error? This did actually work before. It's 2.5, number to Wei. Did I? Last amount paid comes from the contract. Hey, I know what I ran it twice. Did it get rejected? Let's try that. Yeah, I think it got rejected, right? Because I tried to, look, top of the class. Yeah, okay, so there, look, my condition is working, right? We tried to do 2.5 twice, and the contract just errored. And look, it doesn't say very clearly why it errored in the tooling. You got to go hunting for that. And you can actually debug Solidity using some rudimentary tools. But once again, this is something that I expect to get better as time goes by.
If you like 1960s bank terminals with great text,
Yeah. All right, so guys, just to recap, we've set up Truffle in a Truffle project with the directories in the way, the directory structure in the way that Truffle prescribes to us. We've had to set up our deploy contracts file. We've set up our Truffle.js so that we're using the correct network, which is a local one. We've compiled our smart contract to stuff SID.js says. We deployed it to our local blockchain, which is on Ganache, and we've run some tests against it. So so the idea is that you create a large test suite or a good sized test suite to make sure that your contract, doesn't have any holes, because, as someone so poignantly pointed out earlier, that once that contract is up there, the blockchain's immutable, you're stuck with it for life. So you've got to make sure you've got pretty good test coverage generally when you're dealing with smart contracts. Such as 3 tests. Any questions about what we're doing in any of those tests?
So, as Kevin mentioned, JavaScript, notoriously fantastic at floating point mathematics.
Yes.
We had a type in the contract, UN. Can we do type checking within Truffle?
So give me an example.
Like, we want to assert it's a UN, or a UN 32, or a UN 64, or a type again.
That's actually a good question. I think they all come in as a big number, right? Because typically you can have small units, but I don't think you can validate that the type that comes into JavaScript is actually the type that it was in Solidity, because it does a conversion, right? So there's no big number, and there's no medium-sized number, and there's no small number per se. So
the way you would assert that is you could actually look at the API, and it would then show you there's a variable here, it's this type. So all you're basically asserting is, does my contract code look like I expected it to? But yeah, you can assert that that's true. But yeah, Solidity math also can be subject to overflows. Yeah, those things.
So you can try and cause an overflow and then expect it to error. So you can do that, for example. Yeah, that's a...
It's a lower level language. So it's like you get all that same C business of, I'm going to add 1 and then I'll look at overflow and now it's negative number, or I'm all confused.
On the same note, while we're here, SafeMath.
Yes, should use that library when you're doing maths.
Yeah.
Definitely. But that's
This is proof of concept. If you're doing anything like in production, you don't want to be handling millions of dollars with the code that we've got. We're just trying to give you the tools to build.
Yeah, and so if you're building an ERC20 token, for example, that will come with some SafeMath libraries. All the open source libraries you pull in, for example, OpenZeppelin has a whole bunch of libraries, and you pull in the SafeMath. So when you're doing multiplication, it does all your type checking and the types are the right types and all that kind of stuff. Because the nasty one is actually if you're doing a maths where one of them is an integer and the other one's an unsigned integer, you can get some really weird stuff happening because it won't check and it won't cast, and it uses 2's complement to actually define whether something is signed or not. But then the thing they're doing the maths won't actually check that, and you can get numbers this big when you're going, hang on, I just subtracted 1, right? What's going on? From a smaller number, I should say. Yes, because it doesn't recognize the signed bit at the front. It just does I'll take those bits and pop them into a, so that'd be a signed integer, pop them into unsigned integer, and all of a sudden you have, that's a really large number because you have a 1 bit up the front. Does that make sense? 2's complement anyway, it's a nasty one. So there's a lot of pitfalls in Solidity. So love your unit testing when you're doing this. Really, you need to really love your unit testing.
One of the biggest vulnerabilities of a smart contract is people just calling a function. Sounds a little bit funny, but if you were to write a function that's let's restrict transactions so that this is true, and you forget to actually override the default inbuilt transaction one, then people can just call the other function and walk right around you. And there's a lot of stuff like that just requires a bit of different thought process than you're used to, because all the code you see, people can usually see it, see all the values inside of it, and call every function that's there, unless you specifically stop them from doing that. So,
so for example, just to sort of drill a bit down, so if you have this contract, it inherits from another contract. That contract has a function. You forgot about that function when you're doing your testing. Some hacker goes, I'll just call that, and you transfers all your ether out of that address to somewhere else. So you got to be careful. Oops. Yeah, let's...
So hypothetically, how big is, say, mainline right now?
Mainnet?
Mainnet.
Yep.
Is that scan? Right now, we can scan the public internet on a home machine. Sure, that's small enough. You can
Yeah.
the entire thing.
So I've synchronized the whole of mainnet at home. I've got an NBN 100 megabit connection, but it's probably around. It's pretty decent, I guess. Took me about 3 hours, I think, to do that through that. So it's not that bad, and I think it's what up to almost 6 million blocks. I think I saw today on Ethereum. But as Kevin was saying earlier, that's like a challenge. Is what happens when these blocks just keep growing and growing and growing. And I've heard people say, "Well, we'll start truncating them from the tail."
We'll just flatten them in archive and stuff,
But then it's not a solved problem. Yeah.
problem for later.
The one question I had was, Ganache.
Yes.
The version of Geth and Ganache. Is Ganache more like a harness or like kind of an orchestrator, or is it like you can run your own, like I want to upgrade the Geth over here, or is it all packaged together?
So it runs Geth in the background. I'll just verify that. What have we got? So there's an instance of Geth running there. See, that's Geth Rinkaby. That'd be my wallet running. No, actually, it doesn't run it, at least not as the process Geth, but it's running the same code base.
It's basically just running a mocked version. So when it says auto mining, it's not really mining, it's not really solving those math problems, it's just taking transactions and just immediately confirming them for you. That's part of the reason we would use it for unit testing, is because if you had to wait for real mining to happen, that would take 20, 30 seconds for every single mutation. And if you've got enough unit tests in there, you're probably talking about 100 plus. That's going to take a while to run. So this is just taking whatever you throw at it and saying, yeah, that's legit, keep going. And it's running its own little chain, as you saw, starting from just one block. So it's all just kind of a stubbed version of Ethereum is probably the best way to think of Ganache.
Yeah, and there's a command line option as well if you don't want to run the GUI. The GUI is great for presentations, but the command line is probably a bit more useful for scripting this stuff and running it in CI and things like that.
If you were to Wireshark the whole affair, is it all encrypted traffic, or how much is going over open internet? And can you define the encryption?
So if you were to Wireshark, when you say the whole affair, can you be more specific? Look, if we're connecting to Infura, I have to go somewhere else for that source. You'll find it's HTTPS, so that's encrypted. So that will come out as jargon. If you're looking at this server here, it's not encrypted, but that's on the local host, so but generally speaking, the traffic when you're traveling between servers, between nodes, is all encrypted.
But even if it wasn't, you're just signing things and then sending the signed results from the wire. So that they'll be able to tell that you're interacting with a smart contract and which one, but it's up to you. It's just like web traffic. How important is it to you to keep that secure to on the thing you're doing?
Yeah, so that signed transaction, although it's not encrypted, isn't much use to you as just a signed transaction because you can't change it because it's signed, right? So, and it's going to go on the public blockchain anyway, so you're sniffing something with Wireshark going, oh, that's going to go to the public blockchain. And you know what I mean? It's not a very interesting thing to do, I guess. All right, look, I think let's probably leave it there, and Kevin's up next with actually building a front end for this so we can interact with the blockchain with not just tools and command lines and things like that, but actually a proper web page. So yeah, I think let's leave it there. So thanks, guys.